Welcome back to our Algebra 1 series. Today we are up to section 7.5 where we will be looking at inequalities in two variables. In the past we've seen equations like this, y equals 2x minus 1. And we would ask the question, is 1, 1 a solution to this system? This is an ordered pair where both x and y are equal to 1. So we could plug 1 into the equation, simplify, and find out, well, 1 equals 1, so yes, 1, 1 is a solution to this system. What if we had an inequality like this? 2x minus y is greater than 5. We can ask a similar question. Is 5 negative 3 a solution to this system? Again, we would just substitute 5 for x and negative 3 for y, simplify, and get to 13 is greater than 5. Well, that's a true statement. So yes, 5 negative 3 is a solution to the system. It just happens to be an inequality, but the process is the same. Let's jump over to the whiteboard and do some quick examples. Alright, let's take x plus y is less than 4. And we're going to check the ordered pair of 2, 1. So remember, the first one would be x, second one would be y. We can put little reminders up here, x and y. So now we just substitute. So x, well that's 2. We'll say 2 plus y. Y is 1. 1 is less than 4. So 2 plus 1 is 3 is less than 4. Well, that's a true statement. So yes, this is an ordered pair that works for this equation. We're going to squeeze in one more right over here. Well, let's just try to squeeze it in down here if we can. And we're going to say y is greater than 2x plus 1. And the ordered pair that we're going to check is 4, 8. Again, 4 would be x, 8 would be y. So let's just substitute in here. So y is 8. So we'll just put an 8 right there. 2 times x, which is 4. So we'll just write it out with a little here like this. And then we will just barely, we're going to scooch it over a little bit here. 8 is greater than 8 plus 1. That simplifies to 8 is greater than 9. Well, that is not true. We don't like that, which means that this is not an ordered pair that would work for this inequality. Here's a good friend, y equals 2x minus 1. We've seen this equation a number of times. If we wanted to graph all of the ordered pairs that were solutions to this equation, it would look something like this. So any of the ordered pairs that would be a solution to this equation would fall on this line. But what if we had an inequality? What if it was y is greater than 2x minus 1? Well, let's try this point here. Let's see if this is a solution to this inequality. So we can substitute 0 and 1 for x and y to get to 1 is greater than negative 1. Well, that's true. However, it's not on the line that we saw before. This point lies in this zone here. We call this a half plane. This other side is also called a half plane. The line in between the two is called the boundary line. So that goes back to our original question. How do we graph an inequality? All of the points that would make this inequality true are in this half plane that we've highlighted in yellow. What about this point that's on the boundary line, 1, 1? If we substitute x and y for the 1 and 1 as the ordered pair, we get down to this statement that 1 is greater than 1. Well, that's not true. So 1, 1 is not a valid solution to this inequality. So in this case, we would use a dashed line to show the boundary line. Just like we put circles around numbers on the number line when we don't want to include them, we use a dashed line here on the boundary line. The points on the boundary line are not solutions to this inequality. But what if it was y is greater than or equal to 2x minus 1? In this case, 1, 1 is a valid solution to this inequality. So we would use a solid line to show the boundary line. The points that are on the boundary line are solutions to the inequality. So whenever we have greater than or less than, we need to use a dashed line. But if we have a greater than or equal to, or less than or equal to, we would use a solid line. Instead of highlighting an entire half plane in your homework, arrows can be used to show the half plane where the solution exists. Here we have a solid line because it's greater than or equal to, and we put two arrows off of the boundary line to show which half plane the solution exists for this inequality. Let's jump over to some graph paper and do some quick examples. We will also be using the Desmos online calculator to show some quick graphs as well. Okay, let's get rid of this and bring in our graphing stuff. Okay, let's write a couple of functions here. We'll just say x is greater than 2, y is less than or equal to 3, and we'll get crazy here with y is greater than x minus 1. So let's look at this first one, and we're going to mark this one in green. So where is x greater than 2? Remember, x, is this axis here. So where is x greater than 2? Well, here's where x is 2, but it's everything greater than 2. So it's everything to the right of this point. So it's even up here, x is greater than 2. Down here, x is greater than 2. So you can imagine a line here where x is 2, and then everything to the right of it would be filled in. And we'll use those arrows instead of trying to highlight the whole half plane. But it's greater than 2, so we don't include 2. So this ends up being a dashed line. Put a couple more dashes in there. A dashed line like this. And I'm going to put some arrows, and then the direction of the half plane that we're interested in is this way. So I'll even write down here, x greater than 2. Next, y is less than or equal to 3. And we'll do this one in blue. So where is y less than or equal to 3? So remember, y is the up-down axis. So here y is 3. Here y is 4. Y is 6. So it's less than 3, less than or equal to 3. So it's everything below this line. So way over here, y is less than or equal to 3. Even way over here, y, it's negative 2, so it's less than or equal to 3. So because we have an equal sign, this will be a solid boundary line. So it's going to be this entire line, solid, right? And arrows showing that it goes on forever. And it's less than 3, so it's going to be in the negative direction. So we can put little arrows on it like this. So this would be y is less than or equal to 3. Now this last one looks a little more complicated. We'll do it in red. And what I like to think about is this is in slope-intercept form. You can imagine this like our old equation, y equals mx plus b. We have our slope, so our slope is 1, and our intercept is negative 1. So we know we have a slope that has a rise over run of 1, so it's kind of a 45-degree line, and it crosses the y-axis at negative 1. So we have a greater than. So we know the points are going to be, where are we? Negative 1, negative 1. It's a slope of 1, so it's going to be between these points. So I'm just going to put a couple of points. This is where the boundary line exists. We know it has a rise over run of 1. The slope is 1 because of this guy here, because there's a imaginary 1 here. And the intercept is negative 1. The y-intercept is right there. So you know the line is here. If we look at this, it's a greater than. It's not a greater than or equal to. So we know that this line that we're making has to be a dashed line. It's going to look something like this. And an arrow showing that it goes on forever that way. And what are we looking at? Where is it greater than? Y is greater than. So it's this way, where the y goes up. So I'll just kind of cram this in over here. Y equals, whoops, y is greater than, that's a greater than, I promise, x minus 1. That's it for today. If you'd like to see more examples, stick around. First, let's replace all of this. And let's just check some ordered pairs. We're going to put something like negative x minus 3y is less than 18. And we're going to check if negative 3, negative 5 is an ordered pair that works. And we're also going to check 1, 1. So let's start with this one over here, 3 and negative 5. So we have to take this and replace it for x. So this becomes positive 3 minus 3 times negative 5. So we're going to put negative 15 in here. So that's less than 18. So 3 minus a negative, so it's really 3 plus 15. So 18 is less than 18. Well, that's not true. No, we can't do that. So this is a big fat no. Let's try 1 and 1. So 1, go over here, so we have negative 1 minus 3 times 1 is less than 18. So negative 1 minus 3, negative 4 is less than 18. Well, that's a true statement. So yes, this is an ordered pair that works with this equation. Let's get a fresh sheet of paper, and let's do two graphs. We're going to say y is greater than or equal to 4. Let's do x is less than negative 5. And we'll do a little crazy one here. Y is greater than negative 3x. So let's start with this one. We'll do this one in blue. Where is y greater than or equal to 4? Well, here's where y is equal to 4. On this line, it's 4 spaces up. It's greater than or equal to. So you know we're going to have a solid boundary line. So that's going to be here. And it's greater than, so it's this side of the boundary line is this half plane, not this half plane. And we can just kind of jot this in here. Y is greater than or equal to 4. So the second one we'll do in green. Where is x less than negative 5? So we're going to x is left and right. So 1, 2, 3, 5. Here's where negative 1, 2, 3, 4, 5. I can count. Here's where x is negative 5, but we're concerned where is it less than negative 5. So it's everything to the left of this point. Let's count that again. 1, 2, 3, 4, 5. But we can't include the negative 5 space. It has to be less than. So we are talking about a dashed line here. And everything to the left, because we're working on what's less than that. So this is x is less than negative 5. And we'll do this last one again in red. Now again, I like to try to think of this as slope intercept. What is the slope and where does it intercept the y-axis? So the slope is negative 3, and where it intersects, well, it's really 0, right? So b equals 0. So the line crosses the y-axis at 0. So we know this plot is somewhere here. The slope is negative 3. So it has to go down 3 spaces for every space it goes over. The rise over the run. So really it's a negative rise over one run. So we know that negative 3, down 3 for every one here and here. So we know the line is on this, across these 3 points. Where is y greater than? Y is greater than this, not equal to. So we know it's going to be a dashed line because we do not include the points on this line. So where is y greater than it? Well, y is higher than this line over on this half plane, not this half plane. So we can draw little arrows like this and say that this is y is greater than negative 3x. We're going to do a quick bonus problem here. And we're going to start with a line and come up with the equation. So I'm going to draw a line like this. So we have a line. It's a solid line, so we know there's an equal sign in there. So it's asking where y is greater than, so we can start by writing that. We know we were asking about where y is greater than or equal to something. But we're going to kind of cheat again and use this slope-intercept form. So what is the slope of this line? Well, it's crossing these points. It goes up one space and over one space. So the slope is 1. So I'm just going to put, our imaginary 1 here times x. And what is the y-intercept? Well, it crosses the y-axis at -3. So if we were to rewrite this, it would be y is greater than or equal to x minus 3. So we've taken a line and created the equation by looking at the graph. And we'll just write it in here while we're at it. Y is greater than or equal to x minus 3. Before we call it quits, let's jump over to the Desmos calculator and look at some quick graphs that we can do. Here we are at the Desmos online calculator in graphing. You can simply type in something like y equals 2x plus 1, and it gives you the graph. But just as easily, you could take this equal sign and make it a greater than. And you can see it gives us the dashed line and the half plane. If we did less than, we would get the same dashed line and the half plane on the less than side. You can type in the greater than and just hit the equals key, and it gives you the solid line. If we want, we can add another graph here, y equals -3x. It will show that. If we want to, we can move the cursor back, make this a greater than, and you can see the two graphs on top of each other. This is certainly a handy website, but it is important to know how to do these by hand and understand what the graphs mean. And that's it for today. We'll see you next time.